Bismillahirrahmanirrahim. This chapter is all about triangles. Before we get to talking about one of the most important theorems about triangles that you see before you here, I just wanted to review some terminology that we already know about triangles. So I've drawn over here a triangle, and let's label this triangle. It's labeled over here, triangle A, B, C. Now if you wanted to name this triangle, we could say triangle A, B, and C. This symbol here representing the word triangle. So here's triangle A, B, and C. If you recall, each of these pointy ends, that's a vertex of the triangle. So it has three vertices. So vertex is singular, vertices is plural. And each vertex is a point. Point A, point B, and point C here. And as you recall, points are labeled with capital letters in geometry. So A, B, and C are capital letters because they represent the vertices, and those are points in this triangle. So this is triangle A, B, and C. Now we can also say this angle here is angle A, and this angle here is angle B, and this angle here over here is angle C, like this. So a triangle has vertices, it has angles at each of these vertices, and of course it has sides. This is the side that's opposite of A, and this side here is the side that's opposite of B, and this side here is opposite of C, like this. So it has three sides, each of them that are opposite of each of these angles. Now, sometimes if you wanted to label the sides here, the sides themselves can be labeled with alphabets, and typically use like lowercase letter. You can use any lowercase letter such as X, Y, or P, or L, but sometimes sides across from the angles are labeled with the same alphabet with the lowercase. So this side would be side A, this side here would be side B, and side opposite of angle C would be side C, like this. And they don't have to have the same alphabet, you can use any alphabet, but that's the basic terminology regarding triangles. Now this theorem is, as I said, the most basic, most fundamental, one of the most important theorems regarding triangles, and that is triangle sum of angle theorems. I call this the triangle sum of angle theorems, and that kind of makes sense to me. Sometimes some people just call it triangle angle sum theorem, the sum of all the angles. Simply stated, it says the sum of the measures of the angles of a triangle is 180 degrees. That is, the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. That is, if you add this angle up and this angle up and this angle up all together, they would add up to 180 degrees. Now, that's something I'm sure you've known for a very long time, but the question is, why is it the case? Now, it may or may not be very intuitive to you, but we are, inshallah, going to prove this the next time. Today, I just wanted to go through all the theorems and some examples so you'll feel comfortable with the theorems, and next time, inshallah, we shall derive the proof for this particular theorem. Nevertheless, this is the triangle sum of angles theorem, and it states that the sum of the measures of the angles of a triangle is 180 degrees. That is, if you add up all the angles of a triangle, it will always add up to 180 degrees. Okay, so let's do some examples. So here we have a question, and we're asked to basically find these angles 1, 2, and 3. So that's what we're supposed to find. And basically we have two triangles over here, and we're supposed to use the triangle angle sum, or the sum of the angles of a triangle equals 180 degrees to find the remaining angles. Now what we're given here are these. We're given that, we're given that, and we're given that. And if you notice, all the angles are nicely labeled properly, 20 degrees, 78 degrees, and 61 degrees, like this, whereas these don't have like degrees. I mean, of course, because they're labeling angles, so that's not a degree measure. 1, 2, and 3, that's not a degree. It's not like 3 degrees or anything like that. It's the name of the angle, because if you recall, you can name angles also with numbers. So we're supposed to find the measure of angle 1, we're supposed to find the measure of angle 2, we're supposed to find the measure of angle 3. Well, that's not too bad, because if you look at triangle ABC over here, we're given these two angles, and we're supposed to find find angle 3 over here. So the measure of angle 3 is going to be pretty easy. It's going to be 180 degrees minus these two, right? So we're going to take 180 degrees, and you subtract from it 78 degrees, and you subtract from it 20 degrees. We should get the measure of angle C. So if I were to take 180 degrees and subtract 78, and then I can subtract 20 from it, I should get the measure of angle 3 over here. Or I could say I just add these two up. I add 78 and I add 20 together, and I subtract that sum from 180 degrees. I should get measure of angle 3. Same thing. You either add these up first and subtract them from 180 degrees, or 180 degrees and subtract 78 and you subtract 20. And if you do that and you hand it down in your calculator, which I just did, it ends up being 82 degrees. That's pretty easy. So we got this to be 82 degrees like that. Okay, cool. How about the rest of them? You say angle 1 and 2. Well, that might be tricky, but unless you recognize that 78 and angle 2 are vertical angles, and we've learned previously that vertical angles are congruent. So vertical angles are congruent, so the measure of angle 2 is easy peasy. It's simply 78 degrees. So we got this to be 78 degrees. That's cool. Now we know this angle, and then we can find angle 1, which is going to be 180 degrees, and you subtract from it 78 degrees, and then you subtract again 61 degrees, and you get, after you do that, you get that to be 41 degrees. And that's it. That's easy peasy, right? So this is a simple demonstration of how to use the sum of the angles of a triangle theorem to determine some of the angle measures. Okay, so we have two more questions here. Here's triangle, and there's like triangles inside of a triangle. It says triangle JMK, and then there's a triangle KLM. And here again, we are asked to find measures of angle 1 and angle 2 and angle 3. So let's see what we can do over here. If you were to look at this small triangle, you could think, okay, maybe I could start there, but you don't have enough information. All you know is this particular small angle there. And since you don't know angle 1 and 3, you can't really solve for anything over there. But if you look at this small triangle, like this one over here, you can say, I could solve that one, right? Because you know this angle and you know this angle, and so you can find out angle 2. So a measure of angle 2 becomes something that you can solve. So let's see, the measure of angle 2, that's going to be 180 degrees minus 71, and then you have to again subtract 57 from that. So if you use your calculator and then you do this little baby math over here, which I just did, this ends up being 52 degrees. Ta-da! So we have this to be 52 degrees. Now, what do we do with that piece of information? How do we get this and this? Well, there's a couple ways you can do. One thing you can do is, well, you can figure out this, can't you? Because these are supplementary, right? So you can find angle 1 very easily, because that's just 180 degrees, right, minus 57 degrees, because they're supplementary, and that's going to be 123 degrees if I did the math correct over here. So 180 minus 57 is that. Another way I could have done this is, since you know this and you can add these up to get that angle, you can find angle 3, because if you look at the big triangle is going to be this plus this, right? And you add those together, subtract the 180 degrees, you get angle 3. So that's one possible way you can do it. But here I chose to get this angle 1 because it's supplementary to 57. Now I can add these two up and subtract that from 180 degrees. So 123 plus 28, that's 151. So if you add these two up, you get 151. And you subtract that from 180 degrees, I get 29 degrees. So that's easy peasy. So angle 3 is going to be 29 degrees, because I added this particular angle here and added this one, because that's this angle in this triangle and that angle over here, and I can get that again using the same the sum of the angles of a triangle equals 180 degrees theorem, my new best friend theorem. Okay, so there we have it. So that's 29 degrees. So we solved the triangles. That was not so bad. So, okay, now let's try to do this question here. Okay, now you got lots of triangles over here, and there's lots of angles to find here. There's 4, 5, 6, 7, 8, and 9. We're supposed to find all of them angles here. Okay, how are we going to do that? There's one more subtle thing in this question I noticed, is that angle 8 and angle 9 are congruent. How do we know that? Because they're marked as congruent. See, they're both labeled the same way. So if the angles are marked using the same symbol, so here's an angle like this, and here's another angle that marked the same way, that means that they're congruent. So if they're all marked by the same symbol, they are congruent. So 8, once we find 8, we find 9. Once we find 9, we find 8, because they are the same thing. Okay, well, how do we go about finding them then? Okay, let's see. Well, what do we know? Well, this triangle here, this baby triangle, has the most information given there, right? Because we know this angle and we know this angle over there. So using that, we can find angle 7 over here, because we know that everything we need to know in that particular triangle. So I'm going to take my handy dandy calculator here. Look, you can hear the sound of my calculator probably, hopefully. So I'm going to take 180 degrees, and I'm going to subtract from it 65 degrees, and then I'm going to subtract from it 58 degrees. And if I did this correctly, I get to angle 7 to be 57 degrees. The measure of angle 7 is 57 degrees. Well, that's very cool, because then I know I measure of angle 5, which is going to be 57 degrees, because they are vertical angles, aren't they? So okay, so that's 57 degrees. That's cool. I got that to be 57 degrees. Then I can get 6, because that's going to be supplementary, isn't it? Because this is a line, for God's sake, right? So if I find 57 degrees, I can find 180 degrees minus 57 degrees. That's going to be 120 degrees. So measure of angle 6 is going to be 120 degrees. 120 degrees right here. That's measure of angle 6. Okay, and what now? How do I get 8 and 9? Well, how do I get 8 and 9? Well, they're the same, right? So if I take 180 degrees and then subtract 123 degrees here, all right, that will leave me 180 degrees minus that. That will give me 57 degrees, right? That's for 8 and 9, but you have to cut that into half. So, and if you divide this by 57 by 2, okay, so that's what I'm going to do, divide by 2, I get 28.5, so 28.5 degrees. So each one of them is going to be 28.5 degrees, okay? That's 28.5, that's 28.5. I hope I did that correctly, because I'm just doing it along with you. So how did I do this? First, I knew this, so I found this angle. Okay, once I found that angle, I found the supplementary angle, which was this over here. And then vertical angles are like gifts, you know, it's like, okay, so I got this one over here. The last angle is this one over here. How are we going to solve that? Well, we have this baby triangle over here, right? So we can use this baby triangle over there to find the measure of angle 4. Measure of angle 4 is going to be simply 180 degrees minus 67 degrees and minus 57 degrees. If I copied the question correctly and did everything so far, so that's 180 degrees minus 67 degrees and then minus 57 degrees equals 56 degrees. So that's what I get, 56 degrees. So angle 4 is 56 degrees, like that. Ta-da! I think we're done. So I thought this was a cool question, and we had to use a little bit of thinking here. So when you try and do these questions, see which triangle you have the most information about, and from there you try to get as many angles as you can. Vertical angles and supplementary angles are very useful, because if you know the one, then you can get the other one very easily. Okay, so before we talk about the next theorem, we have to know a few more terms. First, I've drawn again here another triangle, and everything that's inside of the triangle, that's considered the interior of the triangle. So if there's a point inside of a triangle, such as this, you would say that point is in the interior of a triangle. So this is called the interior of a triangle. You can have a point, you can have a segment, you can have a circle inside of a triangle, right? You can have any number of figures inside of a triangle. But anyway, all the space, so to speak, the geographic space is in the inside of a triangle is called the interior of a triangle. And by virtue of this, everything over here on the is the outside of the triangle here. So there is the interior of the triangle, and then there is the exterior of the triangle. That's pretty easy enough to understand, right? So every triangle has interior and an exterior. In the same way, you can call these angles over here, if you were to label this over here, A, B, and C, these angles are called interior angles. That is, they're on the inside of the triangle, right? So let's call this like the interior. So angle A, B, and C are on the inside of the triangle, therefore they are called interior angles. So let me just label one of them. So this is a interior angle. So angle A, B, and C are interior. Well, does a triangle really have any exterior angles? Well, actually it does. And that's what we're going to learn next. So the way we generate exterior angles is simply, if I were to take any one of these particular sides of the triangle and just make it longer. So let me take this side over here and make it slightly extend this particular side. So taking this side and made it a little longer. Now, as you can see, here we have this interior angle over here, and then on the other side you have the supplementary angle over here, right? So there's another angle that's generated over here, and that's called the exterior angle right there. This is the exterior angle that corresponds or is supplementary to this particular blue angle over here, isn't it? All right. Now I can do the same thing, but one thing we do have to be careful. Let's say if I go from here to here, right, I can generate another, if I were to extend this particular side like this, I generate another exterior angle over here, right? And in the same way, if I were to extend this particular side like this, if I were to extend this over here like that, and I kind of messed that one up, but if I were to extend this one here, I have generated another exterior angle. So for every interior angle, I have an exterior angle, don't I? So for every interior angle, there is a buddy system, so to speak. There is a exterior angle. So the way one generates these exterior angles, in your mind's eye, you can just extend one of these lines, and this interior angle has this particular exterior angle that it buddies up with, so to speak. And if you were to extend this particular side, this interior angle would have a exterior angle that's associated with this, and in the same way, if you would extend this particular side, this interior angle will have this exterior angle that goes along with that. Now, there's one more thing you can see. You can extend this side here, but you can also do this. Let me show you. You can extend this for every particular vertex, you can extend this, right? But also you can extend this side over here, can't you? Right here. So this particular angle now will have this as its exterior angle, correct? Now, the first time I did this, I extended this side over here, and I said this particular angle has this exterior angle associated with it, correct? But if you notice, if you do this, you basically have two lines intersecting over here, and these yellow angles will be congruent because they're vertical angles. They're the same thing. So it doesn't really matter which one of these two sides that you extend, the exterior angles thus generated will be the same, right? They're congruent. Okay, so our next theorem is the Exterior-Angle Theorem. It's one of my favorite theorems. It's also a very popular theorem in standardized tests and exams in general. So it's a very intuitive and elegant theorem in a way. So the Exterior-Angle Theorem. It states the measure of an exterior angle. The measure of exterior angle of a triangle equals the sum of the two non-adjacent interior angles. Well, it's a mouthful, so let's digest this a little bit, okay? So I've drawn out over here this particular exterior angle, angle 1. So what this is saying that the measure of angle 1, well, the measure of angle 1 is easy because it's supplementary to this angle, isn't it? If you knew this angle, then you can get this angle, and because they're supplementary. That's cool. That's one way of getting this measure of angle 1. But if you didn't know this angle, this particular purple angle that I've drawn, if you didn't know the measure of this angle, you can also get the measure of angle 1 by adding up these two angles. That's what that's saying. So measure of angle 1 is equal to the sum of measure of angle A, so measure of angle A, plus the measure of angle B in this particular diagram. So measure of angle A plus B equals the measure of angle 1. That's what that theorem is saying. It's saying the measure of the exterior angle equals the sum of these two other angles. Now, the reason the terminology is kind of is fancy, see? So this is an exterior angle, correct? Okay, because we always talk about interior angles, right? And we define the exterior angles in terms of the interior angles if we extend the side. But anyway, exterior angle has a neighbor angle, correct? So this is its neighbor angle, okay? And angle A and B are like distant neighbor angles, correct? So they're like farther away from the exterior angle. So exterior angle has adjacent angle, ADJACENT. It has adjacent angle, and then it has two angles that are non-adjacent, correct? Non-adjacent. Okay, so every angle has its supplementary adjacent angle. So every exterior angle has a supplementary adjacent angle, and it has two angles that are non-adjacent, correct? Those are the two non-adjacent angles. So the theorem states that the measure of an exterior angle of a triangle equals the sum of a triangle. Okay, because you can have figures that are non-triangle, they can also have exterior angles actually, but we should get to that later. But here's with regards to triangle, the measure of exterior angle of a triangle equals the sum of the two non-adjacent, here they are, non-adjacent interior angles. Okay, so every angle has every exterior angle has an adjacent interior angle, and every exterior angle has two non-adjacent interior angles. So the theorem simply states that the measure of the exterior angle equals to the sum of the measure of the two non-adjacent interior angles. Now you have to say this theorem a couple of times out loudly until you feel comfortable with how it is articulated, and that's kind of important actually. So you do that because you have to be able to recount these theorems. So the measure of an exterior angle of a triangle, the measure of an exterior angle of a triangle equals to the sum of what? The sum of the two, not one, there are two of them, the sum of the two non-adjacent interior angles. The measure of exterior angle of a triangle equals the sum of the two non-adjacent interior angles. And that's pretty easy, right? Because if you think about this, okay, if you think about this, if you call this angle X, okay, and if you call this angle Y, if you call this angle Z, right, we know that angle X plus angle Y plus angle Z is going to equal to 180 degrees, correct? 180 degrees, right? But angle 1 and angle 1 plus angle X, okay, they themselves add up to 180 degrees, don't they? They add up to 180 degrees. So because they're supplementary, then you can say angle 1 plus x equals 180 degrees and xyz equals 180 degrees. Well, these two are the same, so you can just kind of like do this. X plus y plus z is equal to measure of angle 1 plus the angle x, right? And then watch, you can subtract these two from each side, then you get the measure of angle 1 is equal to y plus z, like this, easy peasy, like that. See, it's like that. So because they these add up, they are all supplementary, and all three of them are supplementary. That means that the measure of angle 1 is equal to the sum of the other two angles, and that's easy enough. And we can do this with an example as well. Okay, so this is the beautiful exterior angle theorem. Again, it says the measure of an exterior angle of a triangle equals the sum of the two non-adjacent interior, not the adjacent, but the two non-adjacent interior angles. This lesson ends with two corollaries, and I would like to talk about this before we do our last example. Corollaries are basically theorems. They're like minor theorems, if you like to say. So corollaries are another word for theorem. They can be proven. Specifically, more commonly, corollaries are thought of as natural extension of a theorem. That is, if you just proved a theorem can have multiple corollaries. Means okay, if this is the one you proved one big theorem, it has a lot of implications. The little baby theorems come out of it. These baby theorems are sometimes called corollaries, but they can be proven, and they're pretty easy to prove usually. So we have two corollaries that come from the triangle sum of angles corollaries. That means they all come from 180 degrees. That sum of the angles, this all come from this one theorem that says that the sum of the interior angles add up to 180 degrees. Now, some of the interior angles adding up to 100 degrees results in some pretty obvious conclusions. For example, if you have a right triangle, that means this is 90 degrees. That means A and B have to add up to 90 degrees, right? If one angle is 90 degrees, the other two must add up to 90 degrees. Well, if that's the case, if A and B add up to 90 degrees, that means they are complementary, because that's the definition of complementary angles, right? Complementary angles add up to 90 degrees. That's their definition. So one corollary of the sum of the triangle sum of angles theorem is that the acute angles of a right triangle are complementary. The acute angles of a right triangle are complementary. You can write it like this: acute angles of a right triangle are complementary. So that is A plus B. These are both, they add up to 90 degrees. That is measure of angle A plus the measure of angle B is equal to 90 degrees, like that. Okay, so that's an easy corollary. There's a second corollary from the same triangle sum of angles theorem corollary. That is the theorem that says that all the interior angles of a triangle add up to 100 degrees. The second thing you can conclude is that there can be at most one right or obtuse angle in a triangle. You can only have one angle that's either 90 degrees or like greater than 90 degrees, let's say 110 degrees in it. Because you can't have more than 10, because if you have like two angles that are like 110 and like 120, but they already add up to 180 degrees. It leaves nothing for the third angle, right? So for that reason, you can have at most one right or obtuse angle. You can't have two obtuse angles in a triangle. You can't have two right angles in a triangle. That's pretty intuitive. So these are two corollaries, pretty easy to appreciate. I think that the acute angles of a right triangle add up to 90 degrees, and then you can only have at most one right angle or at most one obtuse angle in a triangle. Okay, so let's finish off with this last example that your text gives. Here it looks like we're given a rectangle, T, W, X, Y. That's cool. And then we're given a couple of angles and a whole bunch of right angles, which are right over here. And we're supposed to find measure of angle 1, 2, 3, and 4. All right, we can do it. So let's start with angle 1. How are we going to find the measure of angle 1? Well, there's a baby right triangle over here, right? So, and then we just learned in the corollary that the sum of the acute angles of a right triangle are complementary. That means angle 1 plus this 52 degrees, they must add up to 90 degrees. So I just take 90 degrees and you subtract 52 degrees, and then you get angle 1. So angle 1, the measure of angle 1, is equal to basically 90 minus 52, because they're complementary, and that's up being 38 degrees. That was easy. So that's 38 degrees. Now what do we do? Well, we're given another angle over here, 38 degrees, so I can find that one, right? Because these are complementary. Oh, that's kind of cool. That's convenient, because that works out, because this is going to be 52 degrees. So that's going to be basically 52 degrees. That's kind of interesting, right? I'm sorry. I'm messing 52 degrees over here. So this is 38 degrees, so they add up to 90 degrees, and that's cool. And oh, I see a pattern over here. So that's going to be like 52 and 38 degrees over here, right? So because they add up to 90 degrees. And since these two add up to 90 degrees, and so that has to be like, angle 4 has to be like 52 degrees again. Oh, that's kind of cool. I think that's what they're trying to show over here. That if you cut the triangle over here like this, cut the rectangle over here like this, that's what you get. So, that's it actually. I think we found it was kind of easy. So we found angle 1 because there's angle 1 plus 52 are complementary. So I subtracted 52 from 90. I got that. And then 38 was given over here, although you could find that because it's the right angle 2s. And then we found angle 2 to be 52. And then I found that from the big triangle over here. And then this had to be 38 because that's a right angle. So, and then we found this because this triangle is also a right triangle, correct? Or you could say this is a 90-degree angle too. So there's more than one correct way of getting the answer. So that's our final example of the day. I just want to review the theorems that we covered before we finish, inshallah. Okay, so today we learned the most basic and the most important theorems about triangle. That is the triangle sum of angles theorem or triangle angle sum theorem, which states that the sum of measures of an angle of a triangle is 180 degrees. That's angle A plus a measure of angle B plus measure of angle C is equal to 180 degrees. And then we learned the exterior angle theorem. There's the measure of an exterior angle of a triangle equals the sum of the two non-adjacent interior angles. That was a pretty cool theorem. And then we also learned two corollaries from, these are the corollaries from this particular theorem, see, like that. So we learned the corollaries of the sum of the angles of a triangle theorem, and that is the two corollaries were that the acute angles of a right triangle are complementary, that is angle A plus angle B, they add up to 90 degrees, and that there can be at most one right or obtuse angle in a triangle. Inshallah, we shall build on this next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.